So now we're going to talk about something called momentum. If I was on a shopping cart and someone was pushing that shopping cart, then you probably know that for some reason I have something called momentum. But what exactly is momentum with relation to physics? Well, momentum is first written as a small p, right? Power, we have that big P, right? Because power is big, capital P. Momentum is represented by a small p. And it is defined as simply my mass times velocity. And remember, momentum only occurs when you're moving. That was so funny. Okay, but let's just first start off with an example of how we can calculate the momentum of a system. Let's say I'm on a shopping cart, right? And the whole system is maybe like, the whole system might be like 75 kilograms. I'm not sure how much shopping carts weigh, all right? And then I was moving at a velocity of 10 meters per second. What's my momentum? Well, m, 75 kilograms times v, 10 meters per second. So I just say it's 75, and my units turn into kilograms, meters per second. All right, boom, that's how you find momentum. But what if I want to find my change in momentum? I know, that's a weird thing you want to find, but let's say we do want to find our change in momentum. Let's say maybe originally I started at 0 meters per second, and then I changed to 10 meters per second. Well, to find my change in momentum, delta p, I just have to do my mass times my change in velocity. Why mass times change in velocity, not change in both? Well, because in these dynamical systems, our mass is generally not going to change. Because it's not like pushing it or accelerating me or the shopping cart is going to change the mass of the shopping cart. So generally, we can just think m delta v. All right, so that's equal to 75 kilograms times vf, which is 10 meters per second, minus vi, which is 0 meters per second, which is equal to 750 kilogram meters per second. Now, I do want to draw attention to something, and that's this kilogram meters per second. Because I know a newton is a kilogram meter per second squared. Okay, so if I multiply a newton times a second, I get the same units as here. I get kilogram meters per second. Okay, newtons measures force and seconds measures time. So can I say Ft, right? So can I say F of t is equal to momentum? Actually, we can't exactly say that. And there's a very specific reason for that. So let's actually look at what F is. Right? Let's look at what is F. F equals ma. And a is equal to change in velocity over time, right? Well, that means F times t, right, is ma times t. And here I would put a t here, so I get m delta v, which was my formula for my change in momentum. Since change in momentum comes up here, physicists have actually defined a specific thing to mean change in momentum, and that's something called impulse, and it's represented as a j, capital J. So my j is equal to my change in momentum, which is equal to m delta v. The units for j are the same as units for momentum, still kilogram meters per second. Or, now we know, we can also write this as Newton seconds, right? Because we do some basic unit analysis and we can figure out these two give the same units. Alright, so now we've defined 3 specific concepts. And that's awesome. So now let's try to relate this new concept with finding momentum. So let's say I started with an initial momentum, so I will say my pi, or no, let's say I was on a shopping cart. I don't know how I drew it the first time. I'm on a shopping cart, and I'm still my 75 kilograms with the shopping cart, and I started at, my initial velocity was maybe 5 meters per second. And let's say I applied a force of 10 newtons for 2 seconds. Now I want to find my final momentum. Well, how do I do that? Well, f of t is equal to my impulse, right? So I can find my change in momentum. So my change in momentum is f 10 newtons times t 2 seconds, so I get 20 newton seconds, so is equal to 20 newton seconds. Well, I know that my change in momentum can be written as my final momentum minus my initial momentum, right? And we can calculate our initial momentum because we know our initial velocity is 5, my initial mass, which isn't changing through the whole time, is 75. So we just have to do 5 times 75, which is, oh shoot, it's a number like 375? 375 kilogram meters per second. I will just write Newton seconds. Right? Is it that? Okay, I hope it's that. So, what else do we know? We're trying to solve for P of f, right? So I can write P of f is equal to P of I, right? I move the P of I to the right side, plus delta P, which is equal to 375 Newton seconds plus 20 Newton seconds. Okay, so that means my final momentum is equal to 395 Newton seconds, and I've solved it just by relating these three concepts. So yeah, that's an introduction to these three very interesting, very critical concepts. And next time we're going to talk about some laws that are going to that govern momentum. So have fun and bye.